Afternoon. Glad everybody's here. I didn't mention earlier about certificates and CEUs. If you didn't give that information to Jordan when you signed in, maybe you can put the AIA numbers in chat and then we can capture that information. Susan will get that off and getting certificates back. So we want to welcome to our CSI afternoon presentation, Dale Forsberg and Dave Carlson from Watson Forsberg. And Matt Finn from LHB. Matt's a senior architect there. They're going to do kind of a group presentation today on a couple projects they did over in St. Paul. And we're happy to have them be with us this afternoon. And if maybe during the presentation, everybody can make sure that they mute themselves. And then if you want to put some questions as they're speaking in chat, we'll make sure we have some time before we go to jump in and answer all of those as we go forward. So I will turn it over to, I'm not sure who's going first, to Dale, Dave, and Matt, but welcome. We're glad you're with us this afternoon.
Thanks, Chris. I'll start out. I'm Dale Forsberg with Watson Forsberg Tri, and we also have two of our superintendents with us on the project, the two superintendents, Todd and Aubrey, that will, we've got some cool little videos that'll show the construction and they'll narrate that. And then Scott with EP is here too. So I'm going to do just a little bit on the emotional side of the project and give you that flavor for what we did. You know, we were blessed to give 5-6 years of our lives towards this project that's providing, as Tim Marks said, dignified housing for over 600 people in our community. And through that housing, there's a certain portion of it that is called pay for stay. And with the pay for stay, people then, when they move out of Higher Ground or Dorothy Day, they get about $500 towards the next place that they go to. One of our core values is caring for others, and building with inclusion and diversity was important to us, and our partnership with Tri Construction on this project was very significant. Aubrey was a superintendent on the project along with Todd. They worked together as a journey person and apprentice more than 10 years ago, or 20 years ago. So a long relationship there, as well as 10 years that we've been working together with Tri. And they actually did the steel stud and drywall work on the Dorothy Day project, which was over a $4 million subcontract. Another cool piece that I want to highlight on this is the hundreds of supporters that were involved in this project. It was a $100 million partnership for social services, one of the largest in the state, public-private, of which 40 million of the money was private, raised by a committee who was challenged to raise this money in 3 years. They said they thought they could do it in 1 year, and ended up doing it in 2 years. So it showed the community's commitment towards providing this more dignified housing, and we're just so grateful again to be involved in that. So now I'll turn it over to Matt, I think, and the other 5 members of the team who have put this effort in to care for others and build sustainably, and we'll tell you about meeting MNB3 as well. Matt?
Yeah, thanks, Dale. So we're going to cruise through an agenda that's focused a lot on systems and finishes, but I think Dale's introduction on program is an important one. Just real quick, because we know we need to, there are some learning objectives here for those receiving CEU credit today. And then we'll, I think, go around and introduce everybody. So there's a few things here, again, largely focused on systems and finishes, a little bit of time from Scott Vanderheiden on mechanical systems, and then some conversation around constructability. And that's one of the reasons that Todd and Aubrey, the superintendents from Watson Forsberg and Tri, are on the call with us today. You've already heard from Dale and from me, and I think the next thing to do is to go around and maybe we'll hear from folks in this order. Let's hear from Dave Carlson, and then Scott Vanderheiden, and then Aubrey, and then Todd, and then I'll move us on to the next slide. So Dave, if you could introduce yourself.
Yeah, I'm Dave Carlson. I'm with Watson Forsberg. I'm a senior project manager. And I started working on Higher Ground, I guess it was almost 7 or 8 years ago. doing preliminary budgeting for, at that time, Cermak Roads Architects.
All right, Scott?
Hi, everybody. Scott Vanderheiden. I'm a mechanical engineer and managing partner with Minneapolis-St. We were fortunate enough to work on Higher Ground Minneapolis, Higher Ground St. Paul, and Dorothy Day Place that we're going to talk about today. So I'll be talking about MEP systems coming up.
Aubrey?
I'm Aubrey with Tri Construction, and I am a site superintendent. And like Dale said, Todd and I worked together at Forstson Construction 20 years ago, and I was blessed to work with him again on these two projects that we worked at for Catholic Charities.
All right, and Todd?
Hello, Todd Osuski with Watson-Forsberg Construction. Was just happy to be part of the team. It was a big team that almost created to make this happen. So just here to answer any questions that someone might have. So
Todd, I think that's a great segue into the next slide. There was a big team. So as Dale mentioned, Catholic Charities of St. Paul, Minneapolis was our client. They were supported by a variety of funders, both public and private. There are low-income housing tax credits, new market tax credits, general obligation bonds, and money from the city of St. Paul, from the Met Council, and a variety of other sources. So we could go on and on. We could probably cover an hour just on the funding of this project and its implications. On the design team side, I was at Cermak Roads at the time, and we worked with a variety of different partners. Scott Vanderheiden here today from Minneapolis-St. Matson McDonald Young on the structural side, Pierce Peeney on civil, Cohen & Partners on landscape. And I would say there were a few other tertiary consultants on a couple of other trades. And then the Watson, Forsberg, and Tri Construction team was larger. Dave or Dale, any highlights there you'd want to cover today? I suspect there might be a couple folks from these trades here.
Well, certainly Bolander was huge. The site was a challenge, and tunnels and tiebacks, having to get permission from the MnDOT and their retaining wall that was on the site, or tied back into the site. Many of our subcontractors really drove the schedule for us, and grateful for their participation. The modeling of the buildings is probably significant to mention. Gilbert and NAC were the mechanical contractors on the two buildings, and looking at clash detection, that was huge. It really allowed us to perform.
All right, so I'm going to take a minute just to talk about how we're going to move through this today. So I'm going to go through an overview of the two projects together, and then we're going to talk about Higher Ground St. Paul and go through 5 sort of systems on each side. Start with site, then structural, mechanical, architectural, and then talk a little bit about what we learned the most. We'll do that again for Dorothy Day, and then try and wrap up with time for questions by about 10 to 4. So it's on me to keep us moving, and I'm going to talk quickly and as clearly as possible on my sections. So with that, Dale alluded to the site, and for those of you that are not familiar with downtown St. Paul, the Excel Center is right about here, basically across the street from the site. It's a sort of what was the Labor Building in downtown St. Paul, and then a mix of the existing Dorothy Day Center and old mortuary services building, and a couple of other parking lots, a triangular parcel that was owned by the city of St. Paul and had some right-of-way in it and some parking meters. St. Joseph's Hospital is nearby. There's a view corridor up to the Minnesota State Capitol. The Cathedral of St. Paul is also nearby, and a variety of other big institutions. So it's a residential project at the edge of the downtown, but it has a lot of institutional neighbors. The Minnesota History Center and Ordway, there's quite a few nearby. And Dale alluded to the 35E sound wall, retaining wall, is on the west side of the site for the first phase. A couple of images. This whole project, the impetus for the project was to begin to reimagine the delivery of services at the Dorothy Day Center. So the Dorothy Day Center, there's a couple exterior photographs of it, was in downtown St. Paul. Had been on that site for about 25 or 30 years. It was a partnership, close partnership with Assumption Church, which is across the street to the east. And it provided both daytime and overnight services for folks experiencing homelessness. And that's a mix of the services were there. There's a dining hall on the right and a daytime center on the left. Those were their daytime uses. And in the evening, they would be all the chairs and tables were moved and mats we laid out on the floor for people to sleep. And I don't have a photograph of it here today, but oftentimes men and women were divided with a row of folding chairs on the floor. So the goal here was to do two things. One, to really reimagine the delivery of services for homeless folks or folks experiencing homelessness. And then second, to provide a boost of permanent, affordable, and supportive housing on the site. So you can imagine a 30,000 square foot building located in the lower right-hand corner of this image. And now all told, the first phase is Higher Ground St. Paul on the left and Dorothy Day Place on the right. Higher Ground is about 110,000 square feet and Dorothy Day is about 180. So we're going from 30,000 square feet of shelter and services to basically 300,000 square feet of shelter and services and permanent supportive housing. This is a rendering looking off towards the Capitol, which you can see on the upper left. And then we're going to take a walk through floor plans and take a look at some of the interior finishes before we dive into each individual building. So as I mentioned, Higher Ground St. Paul is the first phase on the left-hand side of the slide here. It's a combination of men's and women's shelter spaces, about 230 bunks. The overall program mirrors something that Scott alluded to earlier, which is a project for Catholic Charities in Minneapolis, which similarly stacked overnight emergency shelter on the first floor, pay for stay housing on the second floor, which is basically a slightly more private bunk and bathroom arrangement, and then permanent supportive housing above. On the Dorothy Day Place side, in the second phase, this building was not only larger, but far more complicated. It combines a lobbying and waiting area for about 150 people, a dining service and commercial kitchen for about 350 that serves meals 3 times a day, every day of the year. There's a medical and dental clinic on the first floor, as well as a social enterprise opportunity for Catholic Charities in the future to sort of have an outward facing storefront, essentially, that serves or sort of looks out on the street. The second floor you'll notice that the colors changed here, much more focused on training, computer lab, staff spaces. On the Higher Ground side on the left, you'll also notice a darker blue tone, which is medical respite, which is one of the only medical respite housing functions in St. Paul and one of the few in the state. Medical respite is geared toward folks who have been discharged from the hospital, but that may have a wound, a broken limb, a reason that they can't go back home necessarily. And so this affords them a place to stay as a gap. Let's say if you live on a 3-story walk up and you have a broken leg, you need a place to go for a month or 2 while you heal. That medical respite is also geared toward mental health medical respite. So folks who are not, who need more supervision before they head back home. The medical respite beds are actually co-located with pay for stay. So Dale noted pay for stay on the second floor here. So folks come in the first floor, go upstairs, and are able to check in and have a little more privacy. And there's a photograph of that coming up. On the Dorothy Day Place side, a lot of the second floor is training spaces. That's what the orange is on the bottom, and then a lot of staff spaces. So Catholic Charities has staff of their own, and then also partners with a variety of different agencies, veterans, Ramsey County, some other agencies that come in and provide services to folks. And the idea is that there's what Catholic Charities calls an opportunity center. So it's the most basic needs are met on the first floor, and then the idea is that you move upstairs and move from space to space and are offered opportunities to sort of make a change in the way that you're able to be in the world, whether that's through training, visiting a computer lab, there's a meditation space, there's a personal care room for haircuts and foot care. So a variety of different services are offered on that second floor. And then as we move up, floors 3 through 5 on the Higher Ground side and floors 3 through 6 on the Dorothy Day side are all permanent supportive housing. So the scale of the housing moves from the smallest single room occupancy units on Higher Ground, which are what were loosely called pods, which were relatively small, to an SRO unit, which is about 120 or 130 square feet. The Dorothy Day side, the SROs get a little bit bigger, and they have a kitchen and a small kitchen and a sink, and then shared bathrooms and kitchens. And then there are also efficiency apartments. So in total, There's 194 units on the higher ground side and 177 on Dorothy Day. And the number that Dale mentioned earlier, Catholic Charities talks about it as about 1,000 people, if you count how many come to the site for services or for a meal every day. Before we move on to the higher ground side, I have a few photographs to show of just sort of what these buildings look like. So this is a shot of higher ground St. Paul from the southwest, sort of a frontal elevation. There's a canopy that welcomes folks. They do still queue up in a line outside the shelter and are welcomed beyond the doors, and the gentleman on the bike there. One of the things we are going to talk about is the protected courtyard that's created within this site. And you see the beginnings of that at the close of construction here. This is the lobby and area on higher ground St. Paul. The welcome desk is that clad in blue tile in the background there. And there's a big public art piece, which is a big focus for Catholic Charities and for us to try and ensure that there's not just really welcoming spaces, but that art really should be a part of what we do in providing dignified housing and shelter for folks. This is a shot of the men's shelter in Dorothy Day, or I'm sorry, in higher ground. And you'll notice bunks on the right, which were custom fabricated, designed by us, and then adapted by a contractor to make them even better. And you can see again out in the courtyard on the left. This is the housing lobby. So you see folks at a welcome desk there on the left. And yes, that is me in the computer lab on the right. I sometimes have a second role as a model for architectural photography. So if you need any help, let me know. And then we mentioned pay for stay. This is the pay for stay bunk area on the second floor of higher ground. And then a couple of more common spaces in that building. So for those of you that haven't seen the inside of an SRO, this is what an SRO looks like. It's a relatively small space with an integrated small kitchen. The furniture is all provided by Catholic Charities, so you see the dresser there. And then there are shared bathrooms and kitchens down the hall in this case. A few more slides just around Dorothy Day. This is the second phase of the project. And yes, this is sort of a almost Roman obelisk sort of signage pilaster here outside in the front yard that identifies the property as Catholic Charities. We don't have as many photographs of Dorothy Day because we finished in the fall of 2019, winter hit, and then in the spring there was COVID, and we haven't been back to the building to take as many photographs. So we have a few of the exterior, but not as many. But you get a sense of how the buildings connect to each other. This is an image of the dining room before an event that we attended. You'll see you'll start to see a pretty consistent palette of materials between the two projects. This is a photograph actually that Scott shared with us because we don't have any really of the first floor without people on them, and Scott happened to have one. So you'll see shared bathrooms in the back and then lockers on the right-hand side there, as well as some furniture in that waiting area. Here I am in my modeling role again at a second floor navigator desk. So I talked a bit about folks coming upstairs and being directed to services, whether they're offices on the right-hand side or some meeting spaces and training rooms on the left. And again, you'll see on those yellow boxes are individual meeting spaces for a service provider and a client or a resident. So they can meet one-on-one privately, and then the staff go back to their office on the right. This is a large training room looking out over the city, space for about 80 people, and a really welcoming spot. Catholic Charities has their boardroom or their board meetings in this space. And then we have some shared spaces on the upper floor. And SROs in Dorothy Day are a little bit different. They're a little bit bigger, a little more casework, and they do feel a little bit more homey, I suppose, than the SROs on the first side. So generally speaking, the idea was that you move from shelter to pay for stay to a pod to a smaller SRO to a larger SRO, and then all the way up to an efficiency, which is what these last couple images are. So with that, we're going to move toward a conversation specifically around higher ground St. Paul. We're going to start with site constraints and dig into some of the other structural systems and some mechanical things, and talk at length about sort of the meat behind not just glossy photographs, but sort of how we got there. So that we're going to start both the Dorothy Day and the higher ground sessions with a time lapse. So if for some reason the video doesn't work, you'll have to speak up. And I think ideally we're going to invite Todd and Aubrey and Dave to talk a bit about, to sort of narrate what we see as the video plays. They're about 3 minutes, and everybody likes a time lapse. So this is the Labor Building in St. Paul. And my favorite part is that all of a sudden it disappears. And you'll notice in the
about this phase of the project that we realized that we had some underground tunnels that were underneath the project that we had to kind of figure out what we were going to do, or how the building was going to kind of be over these, if there was going to be an impact or not. But it ended up being, everything was okay. But there's a lot of tunnels in this part of town.
Yep. And you'll notice in the lower left, as it started there was the bedrock was holding water, and it held for quite a while. We even asked the city of St. Paul if they'd allow us to build a cistern underneath that wing of the building. They said no. So we had to squeeze a stormwater tank in the courtyard. So you'll see a precast building going up in the background. Series, they call them towers. They didn't seem like a tower to me when we were drawing them, but they call them towers. And you see the precast sort of gradually moving out into the courtyard. And we'll spend some time later on talking about the thin brick there. In a few minutes here, you'll start to see a couple other finishes go onto the precast. There they are.
Didn't have a lot of room in this part of town here. Our construction limits were really tight. It was quite challenging how to get everybody in and out.
So you'll notice on that, we'll talk about this as we go forward a bit, but you'll see, gray precast panel, white precast panel, precast with mineral wool stuffed into it, precast with thin brick on the outside of it. Pretty soon you'll see some orange brick show up. I think you start to see it on the windows in the background there, which is glazed. And then we'll start to see some composite metal panel show up and be clad on the outside of this. And all that foam, some of it went on the roof and some of it goes underneath the concrete. So there's snow melt here. All right. And one of my favorite parts about this at the end is you can see Todd and Aubrey had their office down here in this square opening on the lower left, which is where the Skyway eventually connects when the second phase comes in. So you'll notice that the lights are on even when it's dark outside. They were there a lot.
That's right, Matt. I remember when we had to cut the thin brick section of this, Matt, to connect the Skyway, and the PSI of that precast was so high that we did not, for a second I thought that it didn't have the insulation in that assembly.
Well, we're all happy that it did, but yes, it's about 10,000 PSI concrete. Oops. Oh boy. How do I go to the next slide? Oh, there we went. Okay. So we're going to start with some more site issues. I know Todd mentioned tunnels under the site. We've talked a bit about the freeway wall, about 20 feet in on the north side of the site, or at least north is up, or north is to the right, but on the top side of the drawing here, that were anchored back with what they call dead men. We managed to expose a couple of the tips of that when the bedrock was being excavated, and was cause for some concern, but it all turned out to be fine. You'll also note that from a design perspective, this orange tone here was the original right-of-way for the street. And one of our sort of early focuses in design was to narrow the street to make it more pedestrian friendly. So you'll notice it was 2 drive lanes and 2 parking lanes on each side. And that what we were really trying to do is set up a relationship across the street that was far narrower. But in the way of that, all these colored lines are different utilities. So there's district energy, there's a 110-year-old water main. Xcel Energy had a big line through here. There's a big transformer out here in the front yard, which served a big chunk of downtown St. Paul. And so the goal here for us was to skinny up this street section, to provide more trees in the street section, but then also to miss all of the utilities. And it turns out there were even more utilities than we realized. So Todd, do you want to talk about that tunnel that you found and called me about?
Well, part of this was in my demo plan. My demo plan told me to take this out of here. So I had to do a little investigation to figure out what I was demoing here, and come to find out it was infrastructure that had stairways that roughly dropped. It was close to 40 feet down to the base of the tunnel. And that's where CenturyLink has all their communication ran bolted on the side of the tunnels down there. They're actually hand carved down there. They look like an archway down there. So you're kind of down in the more of the sandstone that's below the bedrock. So they were neatly sculpted, probably about less than 6 feet, because I had to basically duck my head every time I went down there. But it's being used today as basically a communication ductwork for CenturyLink. So we went down there with a compass to try to figure out exactly where the thing ran, so we could figure out if it impacted the building or not. So it was fun.
But ultimately, it did not get demolished.
No.
It stayed there. So as we keep going here, we've talked a bit about bedrock. This is what that site looked like as the foundations were being installed. There's a lot of rock. And it was a little bit different on the higher ground side than it was on the Dorothy's Day side. We'll talk about that as we get across the street, I think. And then I wanted to wrap up with a little conversation, at least on the site side, with a look at how we dealt with stormwater. So you'll see a tank array on the right-hand slide, which was squeezed in between canopy columns. If you look closely, you can see the footings for those. And we were able to reduce its size by counting the green roof rate reduction, the reduction in rate that was allowed by the having green roofs on significant portions of the upper, sort of these stepped terraces. And there are also restrained rate roof drains up on the high roof to try and slow the water down as it got into the tank, and then ultimately back out into the street. And we took a different approach on the second phase. A few minutes on structure. We had a program here that wanted to be sort of residential in scale at the top on the 3rd through 5th floors, and then gradually needed to get wider as we moved our way down. So similar to a project that we had done in Minneapolis, we leveraged the maximum clear span on a 12-inch plank, which is right about 40 feet. And then we're able to step down and introduce rows of columns as we moved out towards the center of the site or towards the courtyard. Even the canopy is built out of precast. They're solid slabs, center supported, and then little bits in between both sides of a skylight. I made mention of this a couple minutes ago, but as we were looking at the time lapse, but there are, this is an architectural precast sandwich panel. So it's a 7-inch wide of structural precast, 3 inches of insulation, and then a 3-inch finish wide. They're tied together in the factory. And we used it for thin brick, for colored concrete. We attached metal panel to the outside of it. In some cases, we omitted the insulation and the finish wide and filled it in with hand laid masonry. And sometimes we just, there's a couple of areas where there's just thin brick right into the structural wide. This is what that looked like in the plant. We got to do a plant tour out at Wells and got to see them installing thin brick in a form liner, that white sheet on the left. And then I saw them moving some of the panels around. And you'll see reveals, they're integrated window sills and jam flashing bucks around the windows to install the window later. All of that was done in their plant. And then you see some of those pieces getting picked and lifted up into the site. I think this one must be headed up here to the 5th floor on the south side. So you see a white finish wide, the gray structural wide, and then we were infilling with blue metal panels. So you see that missing section in the center there, where we came back with finishes after. Dave or Todd, do you know how long it took for this to go up?
Just the precast portion of it.
Yeah.
It was probably right around 4 months, right around in there.
I would agree. It was 4 months, and then we waited to put the canopy on.
Mhm. So the construction photograph here is a look at the clear span. So you see a shared bathroom in the foreground here, and then the larger windows that would have are turned into SROs. But you can see the corridor wall and the demising walls are all laid out in the ceiling before this pour happened. One of the things that also was different between these two is precast required a lot of core drilling and a little bit of adjustment in where all the plumbing went after the plank was installed. So you'll see there are a bunch of strands laid out here in the precast and then a bunch of holes, trying to figure out where and how exactly that modification was going to have to be made. But it was a bit of a puzzle. Scott, we're ready for you to talk a little bit about energy.
All right. And everybody can't wait to talk and hear about MEP systems. So here we go. So both these projects were state funded and therefore required to be meeting Minnesota B3. Higher ground fell into that 2010 to 2015 timeframe, which meant that this building had to perform 60% better than a baseline building. And that baseline building in this case was that 203 number, 203 EUI. And EUI, for those, I'm sure everybody knows, but just to cover it, is energy use intensity. It is energy performance metric that we can use to compare energy performance. It's a little like saying miles per gallon in a car. And in this case, our target ended up being 81. And we came in as designed at just under 77. Related to that target is the first decision we needed to make. One of the first decisions was, do we use on-site boiler and chiller plants, or do we pull off district energy? Matt mentioned that there were district energy utility lines out in the right of way. And so after some analysis, we did decide to go with district energy. And one thing that did for us is that it moved the EUI target up for us and easier to hit. In fact, as designed, I don't think we hit it without going to district, at least on this project anyway. So move the target up. It meant that the owner did not have to maintain boilers and chillers on site. And if you know anything about district energy, they do have sustainable features as part of their production. So it has primary fuel source of biomass of tree waste. They've got a solar thermal system in the summer. They're making chilled water at night and off-peak times. And so that lent itself well to not only B3, but also just the idea of we wanted to be sustainable in this project. Systems-wise, we, again, pulled off district heat. We did use a 4-pipe fan coil system, which is what we used at Higher Ground Minneapolis. So it was a system they were used to using, along with outdoor air or dedicated outdoor air units with energy recovery, and then LED lighting controls, lighting and controls. So that's how we hit the 77 target. Speaking of air handling units, so this is one lesson learned after the fact. So that green box represents an air handling unit that is on the second floor, and it serves both first and second levels. And while it's a great spot for a mechanical room programmatically, it's not as good of a spot in terms of energy performance. It puts our unit quite a ways away from the last room that it serves, upwards of 370 feet. So current energy codes, high performing buildings would call for that unit to be closer to the spaces that it serves in order to conserve fan energy. And so we learned that. We tried to apply it at Dorothy Day, and I'll show you a slide later on about that. This is an image of the configuration at Higher Ground, which is one fan coil unit that serves 3 SRO units. And it replicates what they did at Higher Ground Minneapolis. Fresh air comes into that center unit as well as exhaust, and then that fan coil serves all 3 rooms. Had we been able to predict COVID was going to happen in 2020, we probably wouldn't have set it up this way. And so you'll see how we did it at Dorothy Day is a little different and provide a little better environment, but that was the arrangement. And then the final topic on this project, you saw images of the courtyard and where the canopy comes out, all has snow melt. So if you're sustainably minded, and hopefully we all are, you might wonder why in the world are we heating a slab up. But this was a very important programmatic element in the project. These 2 buildings put together provide some amount of protection from views, and it is a place they wanted the population to be able to congregate. And so it was pretty important for them to have a good surface for that to happen. Plus, frankly, there's not very many places to put snow. You have to haul it out of there. The one thing we did do is we put the heat exchanger that serves the snow melt on the return side of the building loop prior to hitting the heat exchanger for the district energy. And so we're able to reduce that return water temperature, which is what the district energy is looking for. They want a high delta T and a lower return temperature, which makes their system more efficient. So it served that purpose as well. So that's a very quick overview of systems serving higher ground St. Paul. So back to you, Matt.
All right. So we're going to wrap up the higher ground conversation looking at architectural finishes. And I think you've heard us sort of in different ways talk about bringing a certain amount of dignity and welcome and comfort to folks experiencing homelessness or to folks that are in permanent and supportive housing. So on the left is another view of that welcome lobby. So you see the canopy extending out beyond, and some of those exterior materials coming into that space. Those are really durable polished concrete floor. And one of our priorities was to bring some warmer materials, warmer colors into those spaces. So we were trying to get as much wood into the building as possible, and the wood ceiling was part of that. And it flows not just into this first floor lobby ceiling, but it also extends into some circulation spaces up on the second floor. And if you remember that pay for stay shot, it goes all the way back to the far end of that pay for stay space. So for us, it was really important to introduce not just really durable materials where they were appropriate, but also some materials that sort of softened or sort of made the experience more welcoming. I'll also note that one of the facets of B3 is to have really great acoustical performance. So there's an acoustical blanket over this wood ceiling, and it was a way for us to sort of manage not just the appearance or the image making of that space, but also to get it to perform really well acoustically. On the right-hand side is a common area, a common lounge on the third, fourth, and fifth floors. So that's a space in the housing portion of the building. And again, we're trying to connect color views to the outside, different sizes and shapes of openings. And the kitchen is actually just beyond that to the right. So folks are able to prepare food on the right-hand side and then move over to the lounge space and enjoy a meal. One of the other things that happened in the project was we were able to leverage a specific species of wood. This is natural birch, and every single door in the project is unique. So you'll see 3 different doors here on subsequent floors, and they all have a different grain pattern, and that's consistent, not just in Higher Ground St. Paul, but also in Dorothy Day. That was a really fun thing. I know as Catholic Charities walked donors around the building, they were just floored at the variety of textures and on each of these doors. And then lastly, you get a couple more views of the wood ceiling here, but I'll take a moment. There's a little diagram here that Todd Rhodes drew as we closed our documentation of this project, but you see this big red arrow, which is orienting this canopy here down towards downtown St. Paul. And then there's a couple different pieces attached to it. There's an entry sequence and a stair tower. So this portion of this stair here, there's a whole bunch of glass in these spaces in Higher Ground, which allow a relatively small number of Catholic Charities staff to keep an eye on the various doors and entrances and people moving around the building. And that was really critical, not just to connect back out to the street, but also to provide staff a series of views back through the building. In the left here view, left photograph, that desk there is the desk in the lobby. The desk up here in the second photograph is the pay for stay desk. And then we can see some of those things if you look back through the glass from the exterior. All right. I think we're going to take just a minute. If there's anything that Dave or Dale or Scott or Todd or Robert, is there anything we didn't cover in that sort of high-speed lap around the building that we want to come back to?
Yeah, I was just going to make a comment about the IT systems for for both buildings. Actually, they're joined together, but a lesson learned on higher ground was that all the access control for the building, which were almost any doors that were going into common areas, were controlled, and they were all needed to be part of Catholic Charities server system. And in order to get occupancy, we had to make sure that the Catholic Charities servers were in place and operating before we could even test the doors. And to test all the doors, which were probably 75 on higher ground, it took about 10, 12 days. And we were not anticipating that. And it was a real scramble. And it was a very complicated system. All the fire life safety equipment was also connected to the Catholic Charities servers. So we changed our game plan moving forward on Dorothy Day.
The AMEG system that was used is the same system used at the Pentagon. So the level of security was something new to us. I was just going to share what just hit me as I was listening to this. My grandfather graduated from the University of Minnesota in architecture in 1918 and always claimed he had a photographic memory. I really never got to know that. But if that's what it takes for an architect to do a project like this, Matt has similar capabilities. There were hundreds of drawings, and when we had questions, we didn't have to tell him the detail or the page. He knew what we were talking about and could get us an answer. So it was a cool relationship. So that's a new revelation that just came to me.
Mm-hmm. Well, I'll take that as a compliment, and I will say that
absolutely.
I joined one of the chat rooms earlier, and I said I paid Aubrey a compliment. I said there was the top of the stair tower, which you can see in the photograph here. We were getting the precast was just about done, and there was some steel work that needed to be done to fit the metal panel into place. And Aubrey said, "Man, how do you want to finish this? The drawing isn't quite clear." And I said, "Sure it is." And he said, "No, it's not." And it wasn't. He was right. So it was the start of I would say, a really productive working relationship. So, Todd or Aubrey, anything else you'd like to contribute before we move on to Dorothy Day?
I think you hit it all, Matt.
Yeah, I would say you did too.
All right, we'll keep going. All right, so we're going to start with another time lapse. So I'm going to maybe in the same vein have Todd or Aubrey give us a little. If there are any highlights you see as we get going, and it starts kittywampus, but I promise it flattens out here in a second. So.
Any comments on the electrical and all that had to be moved?
Yeah, before we started there, we had Excel on site moving all that existing power before we even started over there so we could maintain the schedule. There was lots of money spent on moving power over at that side of the building, that's for sure.
It was about $250,000 worth of Excel work. And it took about a year to get it complete.
You saw a basement go on this side, which is one of the things that's different. So there's the south half of the project has a basement. It's all cast in place. And there's a bunch of air handling equipment down there, which Scott will talk about later. This is a PT building, which is different. So again, we're seeing columns and floor plates going up. And tower crane. I'd never worked on a tower crane project before. There's some you'll see a mix of trades here. You see a steel stair tower going up in the foreground. Attached to that, there's a bunch of embeds on the edge of the PT, which we're going to talk about in a little bit. Now, you'll also see all those windows just got wrapped in a wood buck, as we have continuous insulation, and then a bunch of flashing that mitigates between the window and the brick, or the window and the fiber cement panel. Todd or Robbie, what do you call those, the brick things that were up there?
The scaffolding that they used.
Yeah,
The hydro lift.
hydro lift. That was really cool to see that thing go up and down.
Yeah.
So we didn't talk about bird glass on the first project, but we can talk about that for a second now. Because of the B3 requirements, a whole lot of what you see, a lot of the big expanses of curtain wall glazing are all bird safe glazing. And they were shipped from Germany. The IGUs were fabricated over there and they were shipped and then were field installed. Higher Ground had a whole bunch, maybe about $100,000, and I think Dorothy Day had about $250,000 of it. We considered using a product made locally at Viracon. They would either put dots or lines on the glass, and that was deemed not appropriate for portions of the population that may have had experience with the criminal justice system. So we elected to go with a glass that has a UV coating. It looks kind of like an irregular spider web if you look at the glass from an oblique angle. One of the things you're seeing in the courtyard here is another canopy turned sideways and then a green roof on top of it. That's a 215 mil hot rubberized asphalt plaza roof with a bunch of overburden. And you'll also see the joint between the brick building and the fiber cement building and a bunch of glazing that happens there. So that some of the common spaces that I showed on the housing floors are in that notch or slot in the building and provide a little bit of visual relief between the brick bar and the fiber cement bar. I think that's it. It's done. All right. Okay, so we're going to start the same way we did last time, which is to talk a little bit about site constraints. This one's a little bit different. Obviously, Higher Ground was done by the time this one started, so all of the things on the left were in place. On the right-hand side, I made mention of it on the far right. There's a triangular parcel that was owned by the city that originally Watson-Forsberg was just going to use for staging. And ultimately, Catholic Charities entered into a lease agreement to use it for parking. And that was added to the scope. So this is a design drawing that was prepared by Cohen and Partners to talk about the variety of different outdoor spaces and how they tied the two sites together, and then the different perimeter areas. So you see a parking lot on the right-hand side here for volunteers. Catholic Charities has a big volunteer base that a lot of that volunteer effort is geared toward the commercial kitchen and preparing food for folks every day. There's a service alley, which we sort of put together in between an existing building, which has a structural engineering office in it. And then the relocated transformers, and they have an egress stair that sneaks out of the back of their building here that we needed to keep in place. Along the south side here, it faces out towards the Excel Center and toward Cleveland Circle. So if you've ever come into downtown St. Paul, or when you do come into downtown St. Paul, you come down this sort of sloping road here and you see these two buildings on the left. And we wanted to make sure that we had a really great kind of front door to downtown St. Paul. So together these really form really a bit of a gateway. There's a skyway here, which is part of this project, which again kind of forms a gate to the Dorothy Day Place, which is now the name of Main Street. And then one of the more important design features here is that we created an outdoor series of plazas that there's I think what Cohen and Partners calls a bosque of trees, which is a word I learned. And then a bunch of seating, and then there's some really tall light poles here. The idea was that there could be outdoor music being played in parts of this courtyard. And then as we look at the next couple of photographs, you'll notice that, I mentioned the basement on here, but we wedged this building into the property boundary that we had to work with. So I believe that on the left-hand image is excavation for one of the stormwater tanks. So this is that existing building, the neighbor building that stayed. And then Todd or Dave, do you want to talk about the bedrock excavation for a minute?
Yeah, what we discovered was at higher ground, we had weathered rock, which was very easy to chip and peel away. In fact, we had probably 10,000 cubic yards of rock on the higher ground site. And on this site, we had virgin bedrock. And it was, as you can see, it looks just like it was a poured slab. And in order to get that out, we had to line drill, which took a fair amount of time. So it turned out we had about 6,500 cubic yards on this site of rock to remove, and it took probably twice as long.
Other site issues, I know we talked a bit about stormwater on the first project and using restrained rate roof drains and green roof. On Dorothy Day, we did something a little bit different, and I'm gonna have to speak more slowly because it's complicated. So generally speaking, we divided the site in half, west and east. The parking lot and the half of the building went to the east system, which is relatively straightforward. It's just a big tank array. It slows the water down, flows through a sand cushion, and then through that orange arrow out to the storm utility in the street. On the west half of the building, it actually takes a lot more area. And what we did, or what the civil engineer came up with, was to meet the rate and quality requirements. There's a manhole here with a weir wall in it that directs a low flow storm events, basically anything up to about 1 inch per hour, out into the planting area, and uses that stormwater to irrigate the planting beds. It moves through that soil medium, gets picked up in a collection of drain tile, and then hits a manhole here and goes out to the street. At more intense rain events, it still diverts water out to the planting medium, but also kicks any excess water into the tank array to slow it down and store it. And then that flows basically in the same direction, again, all out to the north. It took the city staff a long time to understand exactly what we were trying to do. And it took the utility installation crews on site a while to figure out exactly what we were trying to do. But eventually it was all installed, and it works and helped reduce the size of the tank on this side and allowed us to fit it into what was a relatively small space here and kept that tank a little bit more efficient. All right. I made a note a few minutes ago about the change between or from precast to PT. So similarly, we have a building that has a slender tower and then a wider floor plate on the lower levels, which drove us to try and figure out the most efficient way possible to make that tower, and then how to begin to step it out and make larger spaces on the first 2 floors. So we early on talked with Watson Forsberg about whether or not we should be pursuing a precast building or a PT building. And early on, it became clear that we needed to make the housing units slightly larger, which was going to move us beyond the clear span that was possible in precast. So we knew we were going to have an intermediate column line, which I should have drawn in an orange line here. But that analysis was done in PD and DD to help us figure that out. Dave, do you want to talk about that a little bit more?
Yeah, pretty much what we did is we did a couple of different models that MMY came up with as far as what I should price. And we came up with 2, we did pricing to see which was the least expensive, which turned out to be the precast. But the PT gave us a lot, I guess it reduced the height of the building. If we had gone to precast, we would have gone into a high-rise rating, and which probably would have been more expensive in the long run. So we determined that the PT was going to be the most efficient way to build this building.
Which was an interesting little puzzle for us to try and figure out what to do with, because it really operates as 2 towers and then a variety of other associated systems. So the first phase was really almost all precast, and this one has a mix. There's long span steel structure over the dining area. There's a steel canopy at the entrance. There's a skyway, which is a 110-foot truss on both sides. And then a few other miscellaneous pieces. We'll also note that the PT was stepped down about 16 inches to make that outdoor plaza, and then continues to slope. And that's done twice, once on the west face and once in the northeast corner. And then one of the more interesting things about this was that because the wind blows in different directions on these two towers, it meant that the buildings moved independently of each other. And I carried this little illustration around in my bag for about a year and a half, and I would pull it out anytime anybody asked me why the joint was so big and why we had to hold all the finishes apart. And I flashed this thing. It was pretty tattered by the time we finished the project. But one of the more interesting things about it was that hot rubberized asphalt roof here on the patio had to move across that joint. So Aubrey noted in one of our construction meetings that we needed to take a longer look at the detailing because that wrapped up a wall. It was coming across the joint. The installer had a couple comments about it. And Aubrey, is there anything you'd like to add to that conversation?
Yeah, just when we looked at those details, as Matt said, the Hydrotech has a different tolerance than what the 2-inch expansion joint would allow. So I just remember having to make the horizontal section of that roof 1 inch in width, so we could bridge that gap. And then the vertical section, we had to do some funky details with some L metal and step flashing, so we could make that whole assembly work.
Yes, we did, and I think it all worked out really well. It was an opportunity for us to look at our details again, and I know I really appreciated the whole team's approach at making sure we got that right. One of the other things that we have reevaluated during construction was how we were supporting brick. So you'll see a SketchUp model on the left here, which we put together to try and understand how we were relieving the brick on the building, and then both at the floor line and then hung below the floor line. So you'll see versions of this again in the construction photograph. There's brick relief at the floor line happening up here, and then you see these 4-inch steel tubes that were hanging off the PT with little kicker braces to support brick below the floor line. One of the things that we had come up with during design was a series of bolted connections within the continuous insulation, which then were spray foamed around. And after some conversation with the fabricator and the erector and the Watson Forsberg and with Aubrey and the whole sort of construction team, it was advised that we come up with a system that was welded. So they hot dipped all those pieces together, welded them onto the embed, and then we adjusted our detail with a lot less fuss and a little knife plate coming through that continuous insulation instead of a bunch of steel angles and bolts. And we adapted both of those details to that approach, both the suspended and the relief at the floor line. And then one of the other things that I had never seen before was all of the sleeves and anchors. So on the left, you see that pour, sort of pre-pour condition with not just mild steel, but also PT cable reinforcing, and then all of the sleeving that was installed. And Dave or Todd or Robert, do you remember how many pieces there are out on that deck, on the decks in total?
I think we had right around 35,000 GPS points that were established during all the pours and all the decks.
And one of the most interesting things for me is that once all of the complexity of the pour was done, you ended up with this clear span, like virgin space underneath the pour. And that gradually it all got filled in, but there was this almost Roman appearance to the columns and the plate and the concrete. It was really fun. All right, Scott.
I'm back on. Here we go. So I already covered higher ground. So Dorothy Day fell into that 2015 to 2020 timeframe, which meant we had to be 70% better than the baseline building, which in this case was the baseline was 267, and that's up from the 203 because of the programmatic elements that Matt went through. There's clinics, there's kitchen, there's dining, there's just different spaces. And so our target ended up being 80, and our as designed was 62, which was great. Before I leave this slide, some of the uses: hot water, no surprise, is the highest one for building heating, 46%, chilled water 26, and so on. The most interesting part is that if we were designing this building right now at an 80% savings, our EUI target would have been 53. So we would not have made it as designed. So it's harder and harder. Our systems, still district heating and cooling. We have deployed CO2 control of the higher occupancy spaces. We use energy recovery on almost all of our outdoor air units. We've got LED everywhere and the expanded use of daylight harvesting. But the biggest change between Higher Ground and Dorothy Day is that we determined early on we could not meet the target EUI using a fan coil system. So we switched to a chilled beam system. Here's a visual of a chilled beam. Chilled beam is just a fancy way of saying there's a coil at the ceiling level. And this is an active chilled beam where we're introducing outside air or ventilation air, and it goes through nozzles, and that as it goes through nozzles, it creates a low pressure area and induces air from the room. And the big takeaway here is we don't have a fan. And that's one of the biggest savings that you get is you don't have fan energy in every one of your units. So we went to chilled beam. You can go to the next slide. Here's the layout. I shared the layout in Higher Ground. Here are our 3 efficiency units. And we have a chill beam for every unit. We have outside air and exhaust directly ducted to each of the units. And the anecdotal evidence is that Dorothy Day has fared better than Higher Ground in terms of COVID. And you can kind of see why. So it looks like we predicted COVID in this case. We didn't, but this is the approach we took. So, and then I pointed out in Higher Ground how it would have been better to have units closer to where they were serving. In this case, we did that. We scattered these air handling units closer to where they're serving. So on the left, you can see 2 units, which I assume are in the basement, dashed there on the left. And then we've got rooftop units on the others, again, located where we could, in a shorter distance, get to the space that it was actually serving. I don't have a slide for, but we also have snow melt on this as well. We had 10,000 square feet on Higher Ground. We have upwards of 13,000 square feet on Dorothy Day for much the same reason, and piped in similarly as I described on Higher Ground.
All right.
So that's a very quick overview of Dorothy Day.
All right, we're going to wrap up finishes here and then I think we probably have 4 more minutes for those. I know we're past 4, but I think we just have a couple more minutes to wrap up. What we're seeing here is the exterior of the building facing 6th. That's the housing entrance where it says Dorothy Day Residence. And a little snapshot of the finishes on the south bar of the building, which are field laid masonry, again, aluminum composite metal panel in 2 colors. And there's also some fiber cement on the building, which you see in this is a mock-up panel that was on site. And you see as a Tremco product, we have an impermeable air and vapor barrier because we're outboard of the sheathing, but inboard of all the insulation. And then I made mention earlier about all of the flashing and trims around all of the windows. So this is a mock-up panel that was behind the Watson-Forsberg trailer and was really instrumental in helping us figure out not just all of the brick components and installation, but also how it worked on the behind the fiber cement and behind the metal panel. The orange lines here are Armatherm fiberglass Z's, which we used. We explored a couple different sort of point located furring systems to get through the mineral wool, and decided that the fiberglass Z was a little bit simpler and afforded us a little more flexibility in the long term. And you can see what this looked like in the 3 wall assemblies. So there's hand laid masonry on the left, 5/16 fiber cement panel in the center, and then the composite metal panel and formed at pans on the right. Each of those with 4 inches of continuous insulation on the exterior. And then you see those little fiberglass C's through the center. So this is a far different envelope than higher ground, where we had a whole bunch of concrete. And this one, it's basically steel studs, chipboard, and finished materials. So it's a very different approach. On the inside, there's a similar appearance, a consistent set of materials. You see that same wood ceiling on the left. We did make a cognizant or a conscious choice to switch away from what was glazed face CMU, which we knew to be extremely durable. But that for Dorothy Day, the takeaway for us was that, if we broke a corner, which is a special shape, but also the most vulnerable around some of those reception desks, there are corners as attic stock, but they're really heavy, and it would be really onerous for the facility staff to take one of those corners apart and retooth in a piece. So in this particular project, we switched almost entirely to glazed face ceramic and porcelain tile. So that blue tile in the back is, again, a tile product that really should be far easier and simpler for repair. It was not necessarily super easy in installation, but it certainly should make the facilities management a little bit easier. And again, you see some of the same materials we talked about. So there's the tile at the desk. Again, there's a consistent approach of using warmer and more durable materials where we could, and orienting folks to these navigation desks and welcome spaces. I talked a little bit as we looked at the time lapse about this notch in the building and connecting the circulation space between the floors, but also back to the exterior. So you see a green roof through the curtain wall in the back of the image on the left, and you can see that notch expressed not just in the overall mass of the building, but as we work down and scale all the way down to the circulation spaces inside the building. So you sort of are allowed to, or sort of encouraged to move up through the building, but then to look back out onto the landscape. And again, this is a photograph we showed at the sort of outset, but it's a look at the dwelling unit. And again, trying to strategically use warmer materials where we could, not into, there's a overhead barn door on a track here, and it's using one door slab to cover either a closet door, the electrical panel, which is behind the door in the photograph, or cover the bathroom door. In an efficiency unit, there's not the same kind of acoustical privacy concerns, but we wanted to make sure that there was an opportunity to do something a little bit different, a little more interesting with how the unit laid out. And again, you can see the impact of what it's like to have a big window in the end of an efficiency unit. So we've got a couple lessons up here on the screen, but any takers on those, either Scott or Dale?
Just one point
how
on
much concrete was pretty difficult to deal with from a scheduling standpoint, because we had to pour all those slabs and then polish them before we built the walls. It was just too difficult for them to polish. Otherwise.
I know. I'll take taller floor-to-floor heights. I know this was something we figured out early on. We were limited by the size of panel a precaster could make for higher ground St. Paul, and the PT allowed us a little more flexibility there. We went from a 10'8" floor-to-floor to, I think, a 13'4". I think we added a 1'8" to the floors, and we're able to fit. It allowed us to move all the air for the chilled beam system. Install a finished ceiling in all of the upper level spaces. We didn't see a corridor in higher ground St. Paul, but there aren't finished ceilings. And the PT contributed to that conversation because we had a 7-inch slab and no drop beams, whereas in the precast building we had a 12-inch slab and we had some beam locations we had to sneak under.
with the exterior wall detailing, people may be aware that the building across the street burned to the ground this past summer. nearly 300 feet away, but that mineral wool insulation did a good job of protecting the sheet air barrier from damage because of that fire. There was nearly 7 figures of damage to the Dorothy Day building, with windows breaking because of the heat, panels, oil canning, and at the corners, some of the air barrier melted, but in general, it actually held up well to that kind of abuse.
Scott, do you want to take on the integration for SB 2030?
Yeah, the point there is pretty straightforward in the sense that, especially like I pointed out, as the savings ratchet up, it's key, and it was a key in this project that we started our energy model right out of the gate on Dorothy Day. It took a really integrated process between us and Matt and his team, and to get there, to arrive. And that's the point of that, is that it takes team effort. It takes early planning to get where you need to arrive at from an energy performance standpoint. And the fresh air and energy recovery, I kind of covered that, but we use energy recovery wherever we could. And that obviously putting energy recovery on fresh air intake is a huge saver of energy.
And then how about Todd or Dave or Aubrey on clash detection?
Well, on the clash, it did take a long time. I think we worked on it for 3 or 4 months with NAC, who was the subcontractor. And the advantage that you have, though, is all, Todd said there were 35,000 points that were plugged into the model, that eventually were put onto a Trimble and taken from the model and pointed right onto the deck. So it was really an efficient way to construct the building.
All right. Well, then we have another project on the boards, another shelter project in Minneapolis that Scott and Dave and Dale and I are in the preliminary stages of working on. And the sorts of things that we're talking about a lot are related to COVID and other airborne pathogens. We're continuing to talk a lot about smoking. How you bring in air, where people go to smoke, do they smoke indoors? We could have spent an hour just talking about smoking in the 2 buildings, as it does happen. And then some lessons on flooring. I think Dave mentioned a little bit about polished concrete, and I think knowing that it's complicated and whole buildings of polished concrete, I think our lesson is that we might choose other materials where we can to reduce that coordination and schedule burden. So I think I'm going to stop the screen share for now and see if we can answer some questions for folks. And I'm not sure if Chris or Nancy wants to give us a sort of a guidepost on how much time we should spend. Should we take 10 minutes, take 15? What do we think?
Let's go to the bottom of the hour. We're at 4:12 right now.
Okay.
Don't be shy. People just want to unmute, jump in, or if they're not wanting to speak, they could put something in chat. Just as people are thinking about that. So you ran into a lot of energy issues, some tunnels. What did that do with your budget?
I don't know that the tunnels had a lot. They didn't have a huge impact on the budget. We basically were allowed to leave them alone. The bigger impacts on
issues.
Yeah, the bigger impacts on budget had to do with increases in scope brought by the owner. They were comfortable spending their contingency when it was appropriate to spend it, and those had a far greater impact on the budget than most of the things we discovered in the field.
I'll chime in. I'm not, I kind of got into this a little late, just got in right about 2 o'clock. So you may have covered this, or maybe you won't be able to, but is there a figure you can share with us, the cost per square foot for either building or for both buildings?
Total cost for higher ground is just over $30 million. So you divide that by about 110,000 square feet, you're right about 300. With all the change orders, everything in, it was about 32 maybe.
Yeah.
Dorothy Day, it's 180,000 square feet. Total budget, I think, is, once the triangle was added, I think was 54 or 55 million. Dave, is that right?
54.
54. So similar budgets for both projects. They're in the 330 or so per square foot range.
And what version of the B3 were you under? The same for both, since they were kind of in 2 different time periods?
Scott, you might have to correct me if I'm wrong here, but I think it's 2015 and then pre-2015 and then after 2015.
That's exactly right. I don't remember what version, like 2.1 or I don't remember those numbers, but it was 210 to 215 was higher ground, and then 215 to 220 was the time frame that Dorothy Day landed. Yeah.
So we flipped from 60% better to 70% better between the two projects.
Right. Working towards net zero, as we all are.
And the next one is 80, and it's a it's a big number. There's one question in the chat here about acoustical absorption. So the majority of our approach to acoustical absorption was to use the ceilings. Obviously, with a bunch of hard materials on the walls and floor, really the only surface we had to work with was the ceiling. So in all of those big spaces, we were looking at ceiling materials that were in a NRC range of above 0.9 and in some cases above 1.0. So that wood ceiling, with the acoustical bat that we added, we were 1.0 or so. The irregular geometry in that space helped us some. The shelter sleeping spaces had big acoustical ceiling tiles in large format that were in a 1.0 or so range. And then we did something very similar across the street. We were again using the wood ceiling with the bats over the top in a lot of the big spaces. And then in larger other spaces with acoustical ceiling tile, we were just using acoustically enhanced ceiling tiles.
Matt, this is Joe. I'm the one that sent the
Yeah,
text
you are.
message there.
Yep.
So had you had the opportunity to do any on-site testing for acoustics, or any experience once the building got occupied?
The only testing that was done before the building was put up was a 24-hour sound test that was performed by our acoustical consultant who flew here from California to do it, just to make sure that we didn't need to improve the performance of the window systems facing west towards the freeway. And we ultimately did not do that. Post-construction, St. Paul does not require STC rating or sort of sound testing of the dwelling units, which would have given us some indication of how they were performing, at least on the unit side. But no, not in the majority of the public spaces, we did not. I will say, from walking around in both buildings when they're fully occupied, they feel like you're in a room with a reverb time that's at 3/4 of a second. I mean, they feel right.
Excellent. Good to hear that. Thank you.
So on the building that had the concrete plank, did you guys do a topping on that and then polish that concrete?
Yes, there's an acoustical mat, a pretty hefty mat. I think it's 3/4 of an inch, and then a 4-inch nominal topping. So once it was fully poured and the camber was out of the plank, we anticipate that it was about 3 inches thick. We had a similar approach. One of the things that Dave mentioned in the analysis between the precast and the PT was that we were able to reduce the topping thickness because the PT is flatter. So we changed from a 4-inch nominal to a 3-inch nominal topping between the two projects, and tried to recognize that savings in that analysis.
What was it like working as a contractor, a group of contractors on a polished floor that was already in place prior to a lot of the work, subsequent work?
Well, on phase 1, we covered it. We covered all the floors with, they call it a ram board. And that became really difficult to work with. And we discovered on phase one that really the polished floors are pretty bomb-proof and held up remarkably well with all the trades going through. The only trade that we worried about were the pipe fitters, and we required them to make sure that they were, when they cut and did their work, that they covered the floor. But otherwise, they were easily cleaned. So
I can echo that. We were satisfied too. We were a little worried when Dave said, we're not going to cover the floor. I said, really? You're not going to cover the floor? But it worked out fine. The corridors were more covered, I think, in places.
Yeah.
Yeah, polished concrete becomes significantly harder, and you're using hardening agents and things like that.
There's a question in the chat about nailing down the selection of finished materials, and we didn't necessarily have all the colors picked early on, but we, in order to move through site plan review and to satisfy the owner's expectations for what the buildings were going to look like, and to help their sort of marketing and fundraising efforts, we at least had the majority of the finished materials figured out pretty early on. Both projects moved through a funding application process through the state of Minnesota, and then ultimately through the general obligation bonding process. So we had to have a pretty good picture of what we were going to use and how we were going to use it, really in preliminary design.
How have the buildings kind of performed with COVID? I know you weren't designed for that, but that kind of impacted you as you opened. You mentioned, and I think there was maybe Scott mentioned that one building had some better performance, but you got a lot of group settings. So how has that worked out?
I've been in touch with the facilities director, a woman named Abby Stone, who was at Catholic Charities. And we alluded to that smoking has an impact on these buildings. So in both cases, the mechanical systems were designed and the housing floors for 100% fresh air. On Higher Ground St. Paul, the first phase, residents are allowed to smoke in their units. So even though they're sharing one fan coil for 3 units, we're bringing 100% fresh air, which has helped. They did have some cases per floor early on in March and April, but that has since subsided, and they haven't had a lot of cases in the sleeping spaces. Again, those are relatively high volume spaces, and I think they've managed to spread out or reduce the number of people that are in the shelters. And on Dorothy Day, because there's one fan coil per unit, and because of the individual ventilation, and again, 100% fresh air, they've seen less caseload, or less COVID caseload in the units.
Thank you.
All right. What about Brent? I see Brent. I know Brent. No questions, Brent? Just waving? Oh. All right. Any others?
Any final thoughts?
I have one
I think
question.
there was one in the chat.
Go ahead, Susan.
I have one question related to the comment about the finishing of the concrete floors, the polishing. Is that standard that the floors need to be finished before the walls go up?
Well, you could do it with the walls in place, but it would probably take 3 or 4 times longer to actually do, which would increase the cost per square foot to get the work done. So that would have blown the budget. Then you're better off selecting a totally different approach.
Yeah, I mean,
It was because you had, actually, that was the primary finish, I think, when I saw all the photos.
Yep.
It just made sense that you would go do all the floors and then start doing the walls. So what was it about it that you said was sort of the headache or the lesson that you learned?
Well, so essentially what ends up happening is like, let's say a typical PT job where that's the finished product, you roll right into rough ends. In this particular case, you start polishing the floors, so your sequencing for rough ends on the mechanical side gets skewed. It gets changed. So the sequencing becomes more of a challenge because we have to dedicate, we have to shut down a floor in order for them to pour the topping and then polish it. So it's, you're not only adding the sequence of pouring the topping, but then you're also adding the sequence of polishing it. So a couple of ways we got around it was we put in all the overhead track. Oftentimes we had the HVAC ductwork we installed, because on the underside of the deck, we were able to do that. But all the plumbing pretty much had to wait until we completed the polishing.
And then once all these floors are polished, now you have to protect them.
Yeah, well, on phase one, we did protect them and found out that that was pretty cumbersome. And on phase two, we didn't. We let it go. And Todd and Aubrey did a really good job of making sure that the subs understood that that was the condition, and that you had to, they couldn't go wild on this stuff, but it did clean up really well.
Yeah.
But you also save some time on the back end as far as floor finishes, because your floor now is finished. So the time you lost.
There is a little bit,
Yeah.
but putting in VCT or carpet, it goes pretty fast these days. I mean, and you can only polish so much.
I think in future projects, we're going to use a little bit less polished concrete and probably a little bit more tile, again, to help with some of that sequencing and to sort of broaden the visuals, and that knowing that tile repair is certainly within the realm of many facilities groups' ability. So it's I think, and we're also seeing some clients asking for a little bit more carpet in offices. So we're trying to increase, sort of diversify the palette a little bit.
I think we're going to leave it there. I wanted to say thank you to the whole team, to Dale, to Scott, to Dave, to Matt, Todd, Aubrey. Thanks to Nancy for helping set this all up. Appreciate everybody's time this afternoon. You guys very pleased. Again, if anybody needs to get AACUs, let Jordan know that. And then look for your announcement for our next meeting on Monday, March 15th.